Welcome back to lesson 11 of the Java Comprehensive Guide, and today we are going to talk about generics and exceptions. So we are covering the last bit of object-oriented programming with generics and exceptions. I should have covered beforehand, but there isn't really any appropriate place to put it, so I'm going to put it with lesson 11. Well, we're almost done with this series. We only have two more lessons left, and those are all useful libraries you can use. So technically, this lesson is the last lesson regarding the core features of the language, and everything else is libraries that I personally use that will simplify your coding very much. So let us go back to Eclipse here. So this is from last time we talked about polymorphism. And you can see we have this throws no such field exception and security exception. So what is exceptions? Well, exceptions, let me just remove all of this for now. Exceptions occur when basically the Java compiler does not know what to do. So basically you have to handle these exceptions because obviously exceptions will occur. So they occur very often in your program. And if you do not know how to handle these exceptions, you could potentially be in big trouble. So today I'm going to teach you how to handle exceptions in Java. So the most common way to handle exceptions is to use try-catch exception. So to do that, we will we'll create a new array. So let's do int num, and then we can do let's see here. We can do int my numbers or num equals int num equals 10. So actually, let's do 1, 2, 3. 3 elements. We talked about this in lesson 4. And let us do, this is like the most basic type of exception. Usually you don't know what type of exception a function throws if you look at the API or the Java doc, which I also talked about in lesson 4. It's what this is, the Java doc. Yeah. So basically we are going to get the 44th element of number. Well, you can see obviously it'll throw an error because there's not 44 elements. There's only 3. So once we run it, you can see Java throws this exception called array index out of bounds exception. So that is this exception. So that's pretty much the most basic exception I can simulate right now. Of course, there are many other exceptions. For example, logging credential exceptions, security exceptions, other exception stuffs. But we are going to just simulate this exception because because we can just do that. So basically we can also remedy this because we want this code to basically not error out because this looks bad. What does this even mean? Why? So we can counter that by using a try-catch statement. I'll show you what I mean. So we want to try this code, which obviously wouldn't work. But we're going to basically catch this exception, which is array index out of bound. You have to type the full exception. Believe that I typed that right. Alright. And then we can name that variable anything. I can do it FG, or I can do exception, or except anything. But E is a traditional norm, just like don't ask why for loops always start with I. It's just how it is. So we can do that instead of making it print the ugly index out of bounds. We can make Java actually print, for example, array is out of bounds, which looks much cleaner than exception in thread main java.lang.array index out of bounds exception index 44 out of bounds for line 3. Well, I mean, that is pretty, specific, but saying like we do that, once we run it, you can see array is out of bounds because it tries this code and it says, okay, we have an exception. Let's catch this exception, and then we'll print. Okay, what happens after you catch the exception? That is what you print. So that is pretty much try and catch exceptions. one more thing for exceptions is that you can create a custom exception. Now here's how we do it. So basically, Java has these exception types. Now, these exception types can be you know, they can be used to our advantage. And to do that, we'll create a new function called, let's do public, actually, let's just do void is adult. And we'll check the age. Obviously, in the United States and some other countries, the age of a legal adult is 18. So we will say if age greater than 18, we do, or greater than equal to, because 18 also constitutes as, alright, we do system the print line, we do you are an adult, just like so. And then if it doesn't work, so we just add an else statement, else we throw, yes, we can throw an exception, custom exception, but not custom type, because there are exception types in Java. Most notably, since this has to do with a number, we do throw arithmetic. How do I spell arithmetic? Let's see. Arithmetic exception. There we go. And I think we do that and then pass it in. You are not old enough. So just like that, I believe since this is a custom Java type, you can see Eclipse is throwing an error because I think we have to, since it's a custom type, we have to construct it with a new keyword. So let's do new. There we go. We got, it's a custom constructor. Throw new arithmetic exception. You are not old enough. And once we run it, let's see. Let's delete all of this, and we will do. It should be boolean because but let's just rename this. This is bad naming. It's not. Yeah, there we go. Check adult. So we can check adult, and then we can do 23. There we go. 23. And alright. Sorry about that. Gotta make that static. If you don't know what that means, watch my previous tutorial on why this will work and this wouldn't work. So yeah, go watch that. But yeah, and then we do you are an adult, which perfectly fine, everything fine. But we can basically crash the program. Not really. We create a custom error, which is if we change this to 13 or 12, you can see obviously this person is not an adult. So you can see we created our own custom exception called you are not old enough. Now, obviously, what type of exception is that? Well, you can see it is an arithmetic exception because we're doing a comparison. And we can specify some notes here. So this is the note. It's saying, alright, basically Java detected something wrong with your math. What's the math wrong? You are not old enough because your age is under 18. So that is acceptance in a nutshell. Very, very, very simple. That's why I decided to do it in a previous video. But, I think now is an appropriate time to do it because next we will be covering something else. But that is exceptions. You can throw exceptions. You can catch them. All of that good stuff. Alright, make sure you catch all your exceptions. It is not good practice just to leave them hanging there. So, next we are going to talk about generic methods. Now, put back your thinking, your OOP thinking cap again. And we will talk about generic methods, which is probably a very useful method for anything pretty much because it allows you to specify the input type. I'll show you what I mean. So let us create this new function called static, and usually we can do stuff like int add, right? That is a return type. We can also do static string add, also a good return type. We can do also, I don't know, not a lot of things. Static double, static void, not return anything. But do you know that you can make the user or the caller specify their own return type? Yes, using exceptions. I mean, not exceptions. Sorry, using generics. Yes, I'm still in that exception mindset. Alright, so using generics, we can create our own custom type method. All we gotta do is we gotta do this little angle bracket thing, alright? And then anything inside. Usually we put E. Why? I don't know. It's just a convention people made up. Just like, again, I'm just telling you, why are we doing for I and not for not for J or for K? Well, I mean, we do, but that's for nested loops. But why not for X, right? It's just how it is. But keep in mind, this can be anything. So you can be elephant, right? That will work, but that's just not descriptive. So we just use E. So just like that, that's how you declare generic. And of course, you have to do your return type, which is, again, this specifies the parameter, not the return type. So we have to do our little return type here, which is gonna be void for this demonstration. So we'll do void, and then we can do something like very, very generic as print array, because let's be honest, arrays can take in all sizes and shapes and all different formats. So basically, that is a very good application of this function here, because arrays, again, they can take in pretty much everything. Now here's where it gets interesting, because if you look at the parameter, we will have to specify whatever it is in E. Again, E will be our type. This is our parameter type, our return type. So our parameter type will be E array. So what did I just do here? Because if you think about it, if we change this to integer, right? Of course, Eclipse is messing up, but we change this to integer, and then we do this to integer array, right? Actually, let's remove that. Right? You see that everything works fine. But if we, same thing, all we have to do is just replace whatever this is. Again, we're letting the user define their own types. So we can just use this, and whatever E is, replace that. For example, if you want an integer array past that, E will be integer, and you have int. So literally just erase E and put int here, right? That's just that. That's just what it means. So that's why we do this, so that you can see it can be used for many different types and not just one type. And now you just do a basic, for each loop. Everyone knows what this means. For, again, E, again, has to relate with the parameter type. For E element in array, right, we print that, and then use our syntactic sugar. If it's one line of code, we do not need to print using the curly braces. So now we do printf because we are formatting. Again, printf is a format function. Print line is not a format function. So we do printf, and then there are some escape string literals, all of that. I'm not gonna teach that. There is a whole array online. Just search up string formatting, symbol, special characters along those lines. But I'm going to use %s to format our array here. So let's do element like that, and now it will format all the elements, and at the end, let's make sure it prints actually to a line. So we do system.out.println with nothing inside, and there you go. So that is our generic function. Looks pretty weird if you think about it, but if you take a look closely, you can see that it is not weird at all. So let us see how we can call this function. Again, I specified that user can define their own function. Let's bring our numbers thing back, which is going to be 1, 2, 3, 4, 5. So 5 number array here, and then let's us call this function. So to do that, we want to do print array. We specify the type. That again, this is our e here, equivalent of e, and then we want to now do the parameter type, which is num. So just like that, we have created our generic function. Let me make sure what this is doing. Print array. Let's see if Eclipse is just bugging out, because I don't know why it isn't working. Whoa. That is the reason why, because we can't actually do this. We have to do a... that is weird, because when we see, we can... Oh! That is the reason why, because we gonna need to use this integer. Let's remove this. I think this will work. Okay, but that's not what I want here. Alright, let us debug and see why this is not working. Because last time... Oh, you know what? I think it might be because integer is a primitive type, and you can't do that. You have to use the non-primitive type. Print array cannot be resolved. Well, let's figure this out together. So you can see that this is very strict. Alright, so I know what the problem is. We can't cast primitive types, so I have to do it like that. But okay, let's retype this. I think it's bugged out. So basically, we can't pass primitive types to print array. Now it works. Yes, finally. Okay, should have known that, but I forgot. You cannot pass your primitive. So anything with the orange color. So you could do int. No, you can't pass that. Double. No, can't pass that either. Char. No. Well, how would you pass a double then? Well, you have to write it out. I know but it's the way it is. So that is how you do. That is how you define. Now, see, you can see everything works fine. Of course, one isn't a double, so let's do that. There we go. You can see we have, when we're doing generics, we can't use the orange keyword, aka primitive types. We have to use the counterpart, which is this integer here, and that is how we do it. So once we run this, now it should work. So again, do not use primitive types. Only use this non-primitive type for it to work. So obviously string will work because it's not a char. So you can see in the bottom it actually printed, so nothing's wrong with my code other than that. But you can see what we are doing with the array. Now we can see that, remember in lesson 5 array list sound pretty familiar, because array list, to do that we do, of course we're not including, but we have to do new array list, right? Array list integer, and then new constructor. Well, doesn't that look familiar? Because if you take a look at that, we got angle brackets. In fact, array list, it's just a giant generic function. So once we import array list, let's see if we can go to the array list where it's defined, and I'm gonna try to open the source code for it, and let's see if our inference is correct. So I hypothesize that ArrayList is a giant generic function. So let us go to this ArrayList. So we go to Java System Library. We go to utility. So we do java.base java utility and ArrayList. Alright. And now we just have to find the constructor, and would you look at that. So, this is the abstract class, but we gotta find the constructor. This is the actual constructor. So you can see, we have some other stuff like collections. Collections, again, talked about in lesson 6, how collections.sort. But you can see, we have this E here, which looks not too different from our generic function, and in fact it is a generic method because we have this declaration of the generic up here. So yeah, it is pretty cool to see, you know, basically we have source code of the Java. So, and when you look at that, we also have this, you know, they throw illegal argument exception, right? We just threw arithmetic exception. But it's really cool if you go in your Java system library and just take a look at what the actual system, you know, core files are doing. Because once you like watch this, you'll see that most of these you can make out. Because for example, this one, look, static, that bracket E, element at, same thing with here, we got static E. And now, of course, they return element E, but we return void, which is different. You know, we have void, but you can see the gist of it is the same. Now, we have, of course, some other, hard stuff that obviously we're not qualified to do, or else we'd be working at Oracle. But I'm just saying, if you want to know, if you want to see how good you are from, for example, how good you are at Java, I suggest taking a look at one of these methods and making out what's going on. For example, I'm just going to scroll to a random method. I'm just going to find a method. For example, let us take a look at this method here, list iterator. So I don't know what it does. Of course, it tells you up here, but let us see what's actually doing. So already I see that we have this return type as another class. So if I guarantee you this is another list iterator somewhere. Yep, it's down here somewhere. List iterator, right here. It's an interface. So interface takes in a generic, and then we have the name. It takes in an index. Obviously, range check for add. This is another function. So let's try to go here if we can, and you can see we go down here. Now this is in this illegal argument exception class. Remember our super, this definitely inherits something. It inherits runtime exception. So that's basically, I'm not gonna go too deep, but you can see we just dissecting list iterator, and boom, we have done it with our knowledge of object-oriented programming and generics. So again, as we're getting to the end of this series, I highly suggest open up one of your source code. You know, you be using like HashMap. We talked about HashMap. You be using HashMap all the time, but what does it actually mean? So you can just scroll down here. Of course, there's a bunch of documentation for you to use, but look at this. What does this mean? You see a bunch of if statements. You already see there's some, parameterized type. Again, this is probably your interface. We have some generics up in here defining some other classes. You can actually trace them, and once you're able to explain what this means, you're pretty much set. Of course, I'm not expecting you to actually create this, or else you create your own programming language. But if you can explain to other people what Java source code is, you definitely are qualified for the job. So that is it for today's lesson. I'm just gonna run again so that you can see that that's how generic works. We talked about exceptions and generics, and would you look at that? We are almost done with the series. We're done with all core language features. Next class, we're going to talk about input and output streams. Very useful if you're writing to files and all the other junk and taking input from users. And then, yeah, we pretty much have 2 lessons after this. So if you enjoyed this video, please leave a like and subscribe, and I'll see you in the next one.